So this is another distance problem. This one differs a little from the other one. We'll see in just a second. We have DeLuca's going to be flying in an airplane. In this case, we are actually given the speed of 20 miles per hour, and it's the wind. So we're given nature's speed, not the speed of the airplane. And we do know that it takes 7 hours, and one thing I didn't make explicit that I will right here, and I put it on a post in Google Classroom, is this is round trip. So again, we're going to start off with the distance equals rate times time, and we're going to manipulate this equation by dividing both sides by our rate. So we have distance over rate equals time. So we're going to have our time equaling the distance over the rate going out plus the distance over the rate coming back in. So in either way, we still have time equals 2 units of time. So our time we were given is 7 hours, and our distance is 2,368. So if it's round trip, that means the distance going out and the distance coming back in is still going to be the same. It's going to be half of our total distance, which is 1,184. Now our rate, recall from the other video if you watch, is going to be your rate plus or minus nature. Oh, got a little carried away. So for this particular problem, we are given nature's rate as 20, but we don't know DeLuca's rate. So we'll do m for Mikhail. So it's going to be m plus 20, m minus 20. So that's going to be the equation we're going to solve. So I'm going to solve this one just a little different than what I did with the last example. I'm going to just find a common denominator on the right side, and I'm going to cross multiply. So my common denominator will be m plus 20, m minus 20. So we will multiply by m minus 20 over m minus 20, and we're going to multiply by m plus 20. Okay, so if we clean this up, we have 7 over 1 equals, we have m plus 20, m minus 20, and then we have 1184 m minus 20 and plus 1184 m plus 20. There we go. So I'm going to cross multiply here. When I do that, I have 7 times m plus 20, m minus 20. On my right side, I have 1184 m minus 20, 11, plus 1184 m plus 20. So once we FOIL this out, again, it's a difference of perfect squares, so it's going to end up being 7 times m squared minus 400. On the right side, when I distribute and start to simplify things, what I'm left with is 2,368r. So after distributing the 7, I'm left with this quadratic equation. So for this one, I'm going to set it equal to 0. So I'm going to subtract 2368r to both sides. And I'm left with 7m squared minus 2368r minus 2800. Now, typically with an algebraic expression or equation, we would look to try and factor this. But as you can see, these numbers can be kind of messy. Our a value isn't 1. So I'm going to just jump right to the quadratic formula, where my a value is 7, my b value is negative 2368, c value is negative 2800. When you plug that into the quadratic formula, you do end up getting an answer of approximately 339.5 miles per hour. Now you also end up getting one that I believe is somewhere in the negatives, like -3 or so, -1 I believe it was, and we don't have negative travel speed, so that's an extraneous solution. So our solution is 339.5 miles per hour.